Ladies and gentlemen, this is a question on applications of differentiation, maxima and minima. You can always pause the video to read the question and copy down the question. Now, it is given to us that the volume of the container is fixed at 160 pi. The variables in this question are R and H, which means that the container can be fatter, slimmer, taller, as long as the volume remains at 160 pi. The objective of part 1 is to find the total cost of the material used in terms of cents and show the equation given to us. Now, notice that in this equation, there is no variable H, which means that we will have to get rid of H by expressing H in terms of R. So how do we do that? We can use the volume of the container that's given. The container is comprised of hemisphere, which its volume is 2 over 3 pi r cubed, and the volume of cylinder, which is pi r square H. So my first step would be multiplying 3 on both sides to get rid of the denominator 3, and at the same time, I'll be dividing pi on both sides. So with that, my equation will become 480 equals to 2r cubed plus 3r square H. Now to make H the subject, you can subtract 2r cubed on both sides and divide 3r squared. So with that, the subject H is 480 minus 2r cubed divided by 3r squared. Now, the question is to calculate the total cost of the material. So first, I'll be calculating the surface area of the container, which comprises of the curved surface area of the hemisphere, which is 2 pi r squared, plus the curved surface area of the cylinder, which is 2 pi r h, as well as the base of the container, which is just a circle. So I'll put pi r squared. Now, ladies and gentlemen, you cannot merge these 2 pi r squared together because they are made up of different materials, hence different cost. So now I'll proceed to calculate the cost. For the top part hemisphere, the cost to make is 5 cents. So I'll multiply it by 5. For the cost of hemisphere, it takes 4.5 cents. So I'll multiply by 4.5 for the last two terms. Therefore, my cost equation will be 10 pi r squared plus 9 pi rh plus 4.5 pi r squared. So now, because I want to get rid of h, so I'll be replacing this h with the subject that I just proven into my C equation. So 9 pi rh, 480 minus 2r cubed divided by 3r squared plus 4.5 pi r squared as per normal. So simplify it carefully. 9 divided by 3, I'll put 3 here. R divided by r squared, I notice that there is a denominator r there. So I'll be simplifying the cost equation. That gives me 10 pi r squared plus 1440 pi divided by r minus 6 pi r squared plus 4.5 pi r squared. With that, I'll simplify it further, especially all the pi r squared terms. So I'll be having 8.5 pi r squared plus 1440 pi over r, which is what the question wants us to show. And this is my part 1. For part 2, suggest a sensible price, which seems like an open-ended question of the container, that if the company would like to minimize the cost of the container. Now, minimizing the cost of the container is actually a keyword for us to do differentiation, because in differentiation, we find a stationary value, which one of the possibility is a minimum value. To suggest a price, we need to know the cost of the material, which consists of unknown R. In other words, the question is asking us to find the value of R. Then we will have to plug into the equation C to find the cost of material to know that how much we need to charge for the container. So we will first differentiate C equation in terms of R that we have shown in part 1. So in this case, I'll have dC over dr. For the first term, coefficient 8.5 pi stay. For r squared, when you differentiate it, power 2 go to the front, power deducted by 1. So it will just be remaining as power 1, which we usually don't write. For the second term, when you want to differentiate it, you can actually change it to index form, which gives you 1440 pi r power negative 1. So with that, coefficient stays. So 1440 pi stay, power go to the front, so you have a negative 1 here, r to the power of negative 2, because power will be deducted by 1. Simplify it, we will be having 17 pi r minus, don't forget, positive times negative, that gives you a minus sign, 1440 pi over r squared. So to find the stationary value, we have to let our dC over dr equate it to 0. So now we form an equation in terms of r. Now don't worry about pi, because we can always divide by pi on both sides and we can get rid of the pi. And at the same time, remember, we don't like fraction, we can multiply r squared on both sides. So 0 multiplied by r squared, it will still be 0. 17r, you multiply by r squared, it gives you 17r cubed minus 1440. I believe that you can make r cubed the subject. After that, you can take cube root both sides. 1440 divided by 17, which you press the calculator. Please round off the 5 SF because it's not our final answer yet. So you will get 4.3918 5SF. Now, so this is the r value that we are searching for. But before we plug it into our cost equation, we have to verify that this is indeed the minimum value of the cost. So how do we do that? We have two choices. Either we do second derivative, which I will be performing later on, or the first derivative. Now, it is easier to actually differentiate one more time. So I'll be choosing second derivative. When I differentiate the equation second time, I'll be using this equation over here. Of course, you still have the pi there. So 17 pi plus 2,880 pi over r cubed. Now notice that pi is always positive. So when positive 17 multiplied by pi, it will always be positive. As well as r is radius, it is always positive, which brings your attention that this is always positive. So you know that second derivative is more than 0, which means that c is minimum. So now to find the cost of material, I will be substituting 4.3918 into my equation C to get the value. So please use the calculator to help you. 4.3918 plus 1,440 pi over 4.3918. Don't forget the square here. So right now, I'll be getting $15.45. Now, ladies and gentlemen, this is actually the cost to make the material. It is not the price that you'll be selling, because you need profit, you need to pay the worker, you need to pay the rental cost of the factory, you need to pay the machine, so on and so forth. You need profit, and so the price that you suggest must be higher than $15.45. So you can suggest $25, you can suggest $30, you can suggest $50, for example, if you want a big profit. Now, you must be able to suggest a price because it suggests a sensible price. So you cannot give a range of values. So perhaps you can give $30. I think this is a fair price for you to earn money and also to cover up your expenses. That's all from my video today. I hope you enjoyed and you learned something new from it. Now, if you like this video, please give it a thumbs up and subscribe this channel for more videos like this. I have lesson package on application of differentiation. Questions are from school's prelim papers or end of year paper. Do look at the description for more information. Thank you.